This video will be discussing section D and E of Module 1. And before we get into those sections, I just wanted to quickly refer to the end of module activities. We are not going to be doing these. You're welcome to look over them if you'd like to. Sometimes there's some interesting things back there, like fair use. This talks about photoshopping things, airbrushing things. Some module review stuff, which, if we were in a classroom, we might discuss or do something with those things. But anyway, they're there for you if you want those as additional resources, but I will not be covering those things in the videos. So section D talks about vector graphics. Remember that we just talked about bitmap graphics in section C. And then section E talks about digital video. So let's get started on that. So here are some of the things that we'll be talking about in regards to vector graphics. I'm just going to start skipping past these first couple of pages rather than make you look at all of these terms, although there's not very many in this section. All right, so vector graphics. They first appeared on computer screens before photos. They were just really simple shapes consisting of lines and curves. Each one was referred to as a vector. And so this just shows you some very simple 2D shapes, how you can fill it. And then we got into some 3D things and filling those 3D shapes with like gradient. So a vector graphic is a set of instructions for creating a picture. Different than bitmap graphics, which actually store a color value for each pixel. Again, these graphics contain instructions that a computer uses to create the shape, the size, the position, and the color for each of the objects that are in an image. So I'm not going to go into all of this specific things, but they do give you some code here for how a computer might read how to create a particular image. So let's compare vector graphics to bitmap images. So vector graphics have a lot of advantages over bitmaps. One is they resize better than bitmaps. Again, because they're created by instructions, those instructions can be modified for different sizes and placement on the page. Vector graphics require less storage than bitmaps, again, because you're storing the instructions, not a bit pattern for every single pixel like you would with a bitmap image. This third thing mentions that vector graphics have a different visual quality than bitmap images. Not that that's an advantage really, but vector images do have a flat cartoon-like appearance instead of the realistic appearance that you get from a photograph. And then the last one just is that it's easier to edit an object in a vector graphic than it is to edit an object that's a bitmap. So where do you see vector graphics? In a lot of line art, logos, simple illustrations, and other things that might need to be enlarged or made smaller. Again, because the resizing is a lot easier to do with vector images than it is bitmap images. Also, most modern fonts are created from vectors so that they can be resized. So this just gives you some examples of some different vector images that you might see. Notice the font, an architectural floor plan. All right. So vector tools, architects and engineers might use something like a digitizing tablet, and they might hand draw something on paper, but this tablet, or excuse me, on the tablet, but the tablet would turn it into a vector graphic. There are also drawing software packages like Adobe Illustrator, LibreOffice Draw, and many open source softwares out there. So once you have a vector graphic, can you convert it into a bitmap? Yes, you can. You go through this process called rasterizing, and that works by putting sort of a grid over this vector image, and you'd have to determine the color for each pixel. And graphics software is capable of doing that. "3D graphics. So 3D graphics are based on vectors, again, stored as a set of instructions that describe the coordinates for lines and shapes in a three-dimensional space. So these vectors form sort of a wireframe that this says kind of acts like the same way as a framework of a pop-up tent. So it's better described by kind of looking at this car example that they have here. So you can see the wireframe, and this mentions rendering. So, depending on the complexity of the image and the speed of the computer, many, many years ago, it would take hours maybe to render this image as it's placing the outer portion of this car over this wireframe. They mentioned some other really cool features nowadays, like ray tracing. Short little section on augmented reality. It talks about adding computer-generated vector objects to a view of the real world, and it kind of gives you this Pokemon Go example, which I do not play, but I know many teenagers that do. And so these game characters are computer-generated 3D graphics, so vector graphics that are sort of superimposed into the real world. All right, vectors in virtual reality. So a vector animation is a type of motion graphic in which a series of vector images is displayed sequentially to convey the illusion of movement. And each image is called a frame. So if you've done anything with graphics at all in high school, or you just have an interest there, I'm sure you've heard of frames before. And again, here's an image that illustrates it very well. They mention in the creation of that someone may create like the beginning image, maybe an ending image here, and then maybe an ending image here, and then you might have lots of images in between. This one just shows a few, and you have assistants that can go through and create these still images, and then it sort of plays like a movie, so that while it's playing, it simulates movement. So they mentioned CGI here, computer-generated imagery, and they give you some movie creations where you've probably seen this, but this is used to create these special effect sequences for films and, full-length animated movies even. But here it's talking about pre-rendering, because this process of rendering is very time-consuming, and so pre-rendering allows that all that work to be done ahead of time. For you gamers, this section on real-time rendering might be interesting to you. Here's a popular game. Let's see. Well, this says Source Open Arena. I don't pretend to know a lot about games because I don't play them. But this mentions a classic game like Doom and just gives you some examples. And I just wanted to point out here that real-time rendering deals with an incredible number of bits that have to be processed in the moment. And here it mentions to display 60 frames per second, which is very common with today's gaming games. The computer must handle, that's billion, over 2 billion bits of data every second just to render those image frames. And then additional data beyond that to control character movement and gameplay. So that's wow. All right, that is section D. Let's move on to section E on digital video. So a video is a series of still images projected at a rate fast enough to fool the human eye into perceiving continuous motion. Okay, that's just a video. Digital video is a type of motion graphics that uses bits to store color and brightness data for each video frame. Okay, so we've already talked about, storing things in bits for photographs, and so this is, kind of like each frame is being treated as a photograph. And so all the color and all the brightness data has to be stored for that. So that's a lot of things to store. They just gave you some examples of lots of places where you can access digital video. You guys already know this because you are, you've grown up with these things. So I just want to mention here that the quality of digital video is based on a lot of things. We're not going to spend time going through each thing and talking about it, but things like frame rate, resolution, color depth, bit rate, the compression technique that's used, the file format that's used. So there are lots of factors on, how good that quality of that digital video is. Just very briefly, higher frame rates produce video that's more smoothly simulates real motion. And then here's where it mentions acceptable frame rates for modern video games. 30 to 60 is acceptable. Resolution, I think here it's talking about the higher the resolution, the better quality, but again, it takes up more space. Quite a bit on resolution. Aspect ratio, you've probably heard this. 4:3 was the standard aspect ratio for a long time. The newer display screens on laptops and things use a 16:9 aspect ratio. And so a lot of times if you want to play an older movie on a TV, you'll get this like letterbox look on your TV. Let's see, I think that was all I was going to discuss on that page. All right, video compression. So you can scale down the size of a video by reducing the resolution of the video, by specifying a particular destination that produces files that might be, sized better. You can select a maximum file size, choosing a smaller size, and you can choose a lower bit rate. So those things are kind of talked about here. Let's see. That's all I was going to say on that page. All right, video file formats, just like with the other things that we've talked about. You don't have to memorize any of the video file formats, but you probably recognize some of them. AVI, .mov, MPEG, yeah. So can you change videos from one file format to another? Yes, you can, but they have to be converted. You can't just go change the file extension, and that's true with anything. You can't just go change file extension, and I've run into students attempting to do that before, and typically it messes up the file. So you have to use a conversion utility or something. So if you have video software, you can see if it has conversion or export or something called transcoding in order to convert the file to another format. All right, and this last page just talks very briefly about some video variations. You can read about that if you're interested in that. That was kind of a cool multi-camera to capture 360-degree videos. Yeah, that's all I was going to talk about. So this concludes Module 1.